5.3 exponents in scientific notations. Okay, so we are going to learn how to express numbers in scientific notation. Number 2, convert numbers in scientific notation to standard notation. Number 3, use standard notation to do calculations. Okay, so first we need to know what is called a scientific notation. 12 million can be written by what? 1.2 times by what? 10 to the 7th power. So that means current decimal point is here. We move the decimal point to the left for 1, 2, 3, 4, 5, 6, 7 digits until the decimal point is to the right of the just one non-zero digits. So we get a 1.2, and then we times by what? Because we move the decimal point for 7 digits, we put a 10 to the 7th power. Okay, so this number 1.2 times 10 to the 7th power is called a scientific notation of this number 12 million. Okay, well, if we have a very small number, 0.00000012, so in order to get a scientific notation, we move the decimal point to the right for 1, 2, 3, 4, 5, 6, and 7 digits. Okay, we get 1.2. And then we are going to multiply by what? 10 to the negative 7th power, because this is a very small number. Okay, so this decimal point has to be to the right of what? A non-zero digits. Okay, just leave 1 digit to the left of the decimal point, and this digits must be non-zero. Okay. Alright, now let's practice. Okay, write these numbers in scientific notation. Let's try question E and F. Write 30,040,000 in scientific notation. So this equals anyone tell me your answer?
Which one?
Number E. Esmeralda?
That's wrong. 1.3.
1.304, right?
Yeah.
Times by 10 to the 7th. Agree with her? Everybody? Dollars, right? Dollars. So we move the decimal point to the left for 7 digits until it is between 1 and 3. So 1.304. And then times 10 to the 7th. How about F?
Yeah.
Jose?
40.3.
40.3?
Yeah.
If we do 40.3, how many digits are before the decimal point? 40, 2 digits. We can only keep one non-zero digit to the left of the decimal point. So can we do 40.3? Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. Okay, and you get 4.03. Right, Jose? To the left of the decimal point, there should only be 1 digit. Okay? And then times 10 to the what? Negative 10th power. Okay? If we have a very small number, okay, we're going to multiply by a negative exponent. And then there are 10 digits in between, so negative 10th power. This is by writing a number in standard notation to scientific notation. Reversely, how can we write each number in write each scientific notation In standard notation, what should we do? What is 2.04 times 10 to the cube in standard notation? If the exponent is positive, we move the decimal point to the what? Right. Okay, so for how many digits? 3 digits. So we should have a 204 what? 0. Same thing here. Move the decimal point to the right for how many digits? 7, right? 19902. We don't have enough digits. Use what? Zeros. Okay? Comma, comma. If we have a standard notation, the exponent is negative. Where should we move that decimal point? To the left or to the right? To the left. Okay? So, to the left for 1 digit, and then we need 3 more, right? So, 0.000931. Can you try this number D, please? Anyone tell me number B? What is the answer, Jose?
It's going to be 0.0058295.
Yeah. So 0.058295, right? You guys, everybody? Okay, so these are questions about converting a scientific notation to what? Standard notation. Okay. Now let's turn to the next page. Reform the indicated operation, write each answer in both scientific notation and standard notation. Okay, this is a comprehensive question, okay, to test us whether we understand the scientific notation or not. Okay, so as you can see, question A, question C, and question D, they are what? Multiplication question, right? Do you see the multiplication question? Number times by number, it's a multiplication question, number A, C, and D. Question B is a division problem, right? In general, it's a division problem, but on the top is still multiplication, right? Do you see that? Okay. All right. Number E, number F, they're division problem. Okay. So let's do some multiplication and then do some division. Okay. All right. So let's try to see together. Multiply 7 times 10 to the negative 3 times by 5 times 10 to the negative 9. How can we multiply two numbers in scientific notation? What should we do? What should we do, guys? We use number times by number, which is 7 times 5, right? Times by what? 10. Yeah. Powers of 10 by powers of 10. Okay? For multiplication. 7 times 5 is what? 35. What is 10 to the negative 3 times 10 to the negative 9? By using which rule? Product rule, right? Keep the same base 10, add up the negative 3 by negative 9.
So what's that, negative 12?
Negative 12, yes. Do you think this number it is in scientific notation?
No.
Current decimal point is here, right?
Yeah.
So we have to move the decimal point to the left for 1 digit. Then, if we move the decimal point to the left for 1 digit, how can we do with this exponent? This number is from 35 to 3.5, becomes smaller. This power has to be greater in order to be balanced, right? Because we want this product equals this product. So if we move the decimal point to the left, we raise the power of with this exponent, okay? So negative 12, what is 1 greater than negative 12? Negative 11, okay? So move from this step to this step, okay? Move the decimal point to the left. Increase the power of 10. Okay? Move the decimal point to the left. This number is smaller. This exponent has to be greater than the previous one. Because we only move the decimal point to the left for 1 digits, we raise negative 12 by 1 unit, which is negative 11. You guys? Okay, now I want you to try this question A. I'll give you a couple minutes to try question A, this multiplication. 4.3 times 10 to the 7 times 5.6, Jose?
So it's just like, we're not actually writing out the number, or we are?
Oh yeah, yes we are, yeah, thank you. This is in what? Scientific notation, right? This is a scientific notation. We also have to write our answer in what? Standard notation, right? Both. So 3.5 times 10 to the negative 11, this is scientific notation. Can we rewrite it in the standard notation? 3.5 times 10 to the negative 11, what should we do? Move the decimal point to the left for 11 digits, right?
Yep.
So there's 1 digit for 3, so we have to add 10 zeros, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3, 5. You're right. Now try question 1. First, get a result in scientific notation. Then, we write the scientific notation result in standard form. Tell us how to do the problem. A. Jose?
So what I did was 4.3
times by
5.6.
Yes. Then we do 10 to the 7 times 10 to the 5th, right?
It's going to be 10, 12. 12.
This is what do you get here?
Oh, I got
yes.
4.08
times 10 to the 12, right? I heard you said. But is this number in scientific notation?
No.
No. So what should we do?
Move the decimal to the left 1 time.
Yeah, and then how do we do this exponent?
Isn't it 10 to the 11? No.
Move the decimal point to the left, increase the power of 10. Okay? Increase 12.
Oh, 13?
Yeah.
Shoot.
Because previously, this is negative 12, right? Negative 12 plus 1 is negative 11. Here, positive 12 plus 1 gives us what? 13. Okay? This is in our scientific notation. Can we rewrite it in our standard notation? the decimal point to the right for how many digits? 13 digits. Okay, so we have 2408, 3 digits, we need 13. So add 10 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Wow.
Oh, can you move your paper down so I can write that?
Sure. Yeah, move the decimal point to the left, increase the power of 10. How about reversely? If we move the decimal point to the right, we have to decrease the power of 10, right? You ready to try a division problem? Let's look at question F. 2.3 times 10 to the 5th, 4.1 times 10 to the negative 1, divided by 6.8 times 10 to the 3. What should we do at first, guys? We do the multiplication on the top, right? And then we do division. So on the top, we should have a 2.3 times by what? 4.1 times 10 to the 5th times by 10 to the what? Negative 1, right? Divide by 6.8 times 10 to the cube. So, 2.3 times by 4.1. Can you use a calculator and then get an answer for that? What do you get for the product?
9.43.
9.43?
Yeah, that's right.
9.43 times, what is 10 to the 5th times 10 to the negative 1? 10 to the what?
4.
4. When we multiply, we keep the same base, we add up the exponent. So 5 plus negative 1 is 4. And then 6.8 times by 10 to the cube. Okay, how do we do this division from two decimal scientific notation? What do we do? Number divide by number. Okay, 9.43 divided by 6.8 times by what? Power divide by power. Okay, for division, number divided by number times power divided by power. Okay, so 9.43 divided by 6.8. Give me a...
what are we rounding to?
You know, don't round. Just keep the answer.
It's a long number.
It's a lot. Okay.
I got 1.3867.
7?
Yeah, 6.
Oh.
It's a long number.
Let's run it for 3 digits, I would say. Well, 7 digits, right? So 1.3868, or, you know, times by, what is 10 to the 4 divided by 10 to the 3? For division, we just learned the quotient rule, right?
So it's minus?
Yes. So 10 to the 4 minus 3 give us what? First power, right? So, is this number in scientific notation? To the left of the decimal point, do we have only one non-zero digits? Yes. 0 this is already the answer in scientific notation. Let's rewrite the answer in standard notation. This number times 10 give us what? 13.868. This is what? Standard notation. Right? What's up?
So I was looking at E. So do we move the 1 over or no? Because 8 divided by 2 is 4.
Yes.
And
This is 10 to the negative 3 divided by 10 to the negative 4, right?
Yeah.
So for division we use what? Subtraction. So use negative 3 minus what?
negative 4.
Negative 4. That gives us a 4 times by, what is negative 3 minus negative 4?
1.
1. So this is already done for scientific notation,
So
right?
you don't have to move nothing?
No. Scientific notation, that's already scientific notation. In standard notation, it is 40, right?
That's 40?
Because 4 times 10 is 40, right?
Yes. Oh, now I see.